So Euler's method helps us approximate a solution, where the next guess at our solution is found by taking the previous guess and then adding the interval length, which is, I think our textbook uses h, it could be a different level, but this is going to be 0.2 for this question because we have 5 steps over this interval. So this interval has a length of 1. If you divide that into 5 equal pieces, then 0.2 is our h. And then you multiply that times the derivative of the function that we're working with. So in this case, that's negative 3y over here. So x isn't going to matter. But so in each step, we take the previous guess. So we'll say y sub 1 is equal to y sub 0, which is our starting point at this interval, to tell us that 0, we have 1 y value. This is 0.2 like we said, and then this is the value after we plug in our x and our y into our derivative function. So in this case, we're plugging in 1 for y. So this is going to be negative 3 here. So that's going to be 1 plus negative 0.6, so we got 0.4 for our first step. And then you just keep repeating until you reach the end of the interval they gave you. So y sub 2 we found by taking y sub 1 plus our interval length times the value of our derivative at that previous y value that we had. So plugging in 0.4 in here, negative 3 times 0.4 is negative 1.2. That's 0.2 times 1.2, negative, plus 0.4, so that's 0.16 for our next approximation. Then we just keep repeating that process. So our 0.16 was our last known approximation on our steps. So 0.2, and then we multiply this times the derivative at y is 0.16. So I think this notation actually should say n minus 1 and n minus 1 here. Sorry, I forgot about that, but that means the previous step. So we're plugging in 0.16 in for y, so negative 3 times 0.16. That's negative 0.48. That's negative plus 0.16, so we got 0.064. Then y sub 4 be that approximation we just got, plus step size of 0.2, and then we need to plug in 0.64 into the derivative, 0.064, wasn't it? Yeah. So negative 0.192. And this 0.064, so that's 0.0256. Have we reached the end? Because we're at, what were we at for x? This would be at x 0.2, 0.4, 0.6, 0.8. So we got one more approximation in front of us, the fifth one. So we were at 0.0256. Plugging in 0.0256 into that derivative. It's negative 0.0768. Multiply and add. So we got 0.01024. So that's our approximation of the solution of y of 1 using Euler's method. That's what goes in that top box. And in this box over here, solve the initial problem exactly. They gave us the exact solution. So if you plug in 1 into the exact solution, you get e to the negative third power. And to compare your answers, all they want you to do is to take these two numbers and subtract them, the absolute value of the error. Our guess was 0.01024. And then the decimal form of the exact solution of this. So if we subtract those two and just make sure it's positive because they're asking for the absolute value, this would be the error right here.